Alright, so here I have a triangle. Class, what type of triangle is that?
Right triangle.
Right triangle. Now, this right triangle has special marks on it. So, it's either an isosceles, scalene, or equilateral. This is an isosceles triangle. I'm putting this under previous information or knowledge, so you should know that. And it's an isosceles right triangle. Well, there's a couple ideas about isosceles right triangles. If this is 90 degrees, and previously you already copied that if you add up all the angles add up to be how much? 180. So if you subtract 90, you have how much? You have 90 left over, and these have to be equal, so that's what? 45. So 45, 45, 90 is synonymous with isosceles right triangles. If these congruent marks, everyone say congruent marks?
Congruent marks.
It's telling you the sides are equal, and going across, the angles are congruent, or the same. Alright, let's just say I gave you this triangle here. If I tell you to solve for a triangle, solving for a triangle means you have figured out all of the side lengths, that's on the outside of the triangle, and all of the angles, which is on the inside of the triangle. Well, I can probably solve this in a couple of ways. If I wanted to solve for the sides, talk with your partner what you can do. 20 seconds, go. But this is all the information I give you, and that's 1 unit. What are some things we can do? Question?
Like on the test, it's like the sides are the same and the base is equal to the base right or the two.
Yeah, so that's given information. So if I give you this, so in purple, that's given information. You don't have to write anything. You should be able to write 45 degrees. You can mark up the triangle, and you can even write a number. You don't have to write a theorem or anything. It's kind of like almost like basic information. Like I don't need to explain B is the second letter in the alphabet. That's why I use the letter B. We are implied that B is part of the alphabet. Well, if I wanted to find the third side of a right triangle, I can use what? I can use Pythagorean Theorem. Now, pay attention. Is this Pythagorean Theorem inscribed in a circle? Is it on the coordinate plane? Ignoring that I'm doing graph paper. No, so previously you used the Pythagorean Theorem as c squared equals a squared plus b squared. Class, what's the most important letter? And where is c? Across from the right angle. This doesn't matter, these are a and b. Let me show you how to use the Pythagorean Theorem on this triangle so that we can solve for the third side. I'm going to call this one A, this one is B, therefore class this one is C. I'm going to write down the Pythagorean Theorem, and I did write it in this order for a specific reason for other theorems later on. The C value I don't have. My A value? B value? Class 1 squared? 1 squared? 1 plus 1. If I take the square root of both sides, I have c equals radical 2. Caution. Last semester we had said that if you have a quadratic, power of 2, and you take the square root of both sides, your answer is actually plus or minus. I'm only keeping the positive because c represents a distance. Distance is always positive, never negative, so now we're implying that it's only positive. Now, what I have here is something called an exact answer. Everyone say exact? This is an exact answer because if I put in my calculator the square root of 2, I get a number. If I ask you, solve for the triangle and round your answers to the nearest hundredth, that's when you would actually find an rounding to using decimals. If I say an exact answer, let's write that, exact, then you leave it with the radical. So that's using Pythagorean Theorem. Now I'll show you the shortcut. The shortcut is that you have a 45, 45, 90 triangle. And if you recognize that across the 45s, it's the same value. Yes? So we just call that x. Well, these are the same length, so we call them x and x. And then with the 90, it's just the square root of 2 times x. So x radical 2. So how would I do that trick for that problem we just did? Well, I gave you a short leg of 1. So you would just put in 1. Well, x is equal to 1, so every time you see an x, you just write 1. 1, 1 radical 2. And there you have the 3 legs of your triangle using that shortcut. Now that I have the sides there, now I can apply the 6 trig ratios. I'm going to pick an angle. Let's pick 45. So we're going to find 6 trig ratios at 45 degrees. Class, what's one trig ratio that we learned previously? Sine. The other one? Cosine and tangent. Well, I told you to start at the 45 degree angle, and it's kind of weird because you have two 45 degree angles. You always start at the reference angle, and here you can label the sides of the triangle. Class, help me label the sides. This one would be called opposite, adjacent, or hypotenuse. Opposite. This is the opposite. This one would be called the, this one is called the hypotenuse because it's across from the right angle. I've gone in that order, opposite first, then the hypotenuse, and very last, this one is the adjacent. Sine of 45 degrees says I need opposite over the hypotenuse. So class, what is the opposite over the hypotenuse? 1 over radical 2. Now pay attention. You can't leave a radical in the denominator. So we have to do something called rationalizing. Which means I just take whatever it is and then multiply the numerator and denominator. And multiply across. Class 1 times radical 2.
Radical 2.
Radical 2 times radical 2. 2. And radical 4 is 2. My answer is rad 2 over 2. Class, what two sides is cosine? Adjacent over the hypotenuse. Class, how much is the adjacent? 1. And how much is the hypotenuse?
Radical 2.
Radical 2. You can just rationalize that again, and you get the same answer. Tangent, which two sides?
Opposite and adjacent.
The opposite is how much?
1.
And the adjacent?
1.
And that just simplifies to be
1.
So in the future, I'm going to be asking you questions. How much is the cosine of 45? The answer is radical 2 over 2. What is the tangent at 45? It's 1. I can ask you a more difficult question, such as which angle has an exact value of radical 2 over 2? You should come up with both any angles that are both sine of 45 and cosine of 45. Let's do the other three trig ratios. Class, what are the other ones? Cosecant 45. The other one? Secant of 45. And the last one? Cotangent of 45. Boys, what two sides are cosecant?
Hypotenuse and opposite.
Hypotenuse over the opposite. Boys, how much is the hypotenuse?
Radical 2.
It's a radical 2. Boys, how much is the opposite?
1.
Opposite is 1. So my answer is just radical 2. Pay attention here. You could have gone up here to sine of 45 and just flipped it, right? But over here, you already rationalized it, so it would be a lot of work to do 2 over radical 2. You could have come over here and just flipped it. Do you see that?
Yeah.
Girls, secant. Which two sides? Girls, what is the hypotenuse? Radical 2, so I'm starting at 45. And the adjacent? 1. And girls, that becomes radical 2. Remember, you could have gone to its pairing, its reciprocal identity, which we'll talk about later, is I could just taken this one and flipped it. Do you see that? And the last one, class, cotangent is which two sides? Adjacent over the opposite. So you might want to start making some flashcards. Cotangent is adjacent over the opposite. Its cotangent is x over y. So I can just look up here, flip it, so 1 over 1, so my answer is 1. So I can give you a triangle, I can tell you to finish solving it so you have all the parts to it, and then I can ask you for any of the 6 trig